So, scientific communication. Um, an important aspect of science is the ability to tell others what you did and how you did it and what you have discovered. So, this is something that's really important in science, and it often involves writing a report of your investigation. So, you write up a report, and in your report, it is important that you present your information in a form that is clear, accurate, and easy for others to understand. So, they're the kind of main things that you're trying to do. So this may involve, so it could be a written report, and in that report you could use diagrams or you could use photographs, tables to show any numerical data that you've obtained, or the use of graphs, pie charts, or bar charts. And sometimes it involves preparing a poster to outline your work or telling others about your work using like PowerPoint, for example, like what I'm using now, or other multimedia resources. So there's a number of different ways that you can present your information. Um, but there's some key things that are common to all of them that we need to look at. You will have to adapt your presentation to suit the people to whom you are reporting. So, for example, a report to your class who shared the investigation with you might be different from reporting to another class or group of parents. So, for example, you might be buddied up with somebody and the two of you understand completely what you just done. But if you were to present that to your parent, for example, or to another class group who've never carried out the investigation, it's important that it's clear for them that they can understand and see exactly what you've done. And that's kind of like what this is about. And there's a number of different ways you can present. What I like to focus on is preparing posters, and I'll give you an example of that um, in the next couple of slides. But this is kind of like scientific communication, is to think about what it is. So it's the key things that you want in there, but then it's also to understand that you can present your information in a number of different ways. Like you can present it using PowerPoint, you could create a podcast, you could like create a poster, you can then just do up like a written report in your in your copy, or you could type up a written report, for example, in Word. So there's a number of different ways that you can communicate your scientific findings or investigations. So in this section, we will look at the following learning outcome. So students should be able to organise and communicate their research and investigative findings in a variety of ways fit for purpose and audience, using relevant scientific terminology and representations as well. So this here is an example of one of my students' work, and this is taking an investigation and presenting it in the form of a poster. So the presentation or the investigation, as we see, it was about conductors of electricity, and I'm going to talk a little bit about that, and you're going to actually carry out this experiment as well, and you're going to report on the experiment. So conductors of electricity. So what's really important, these are the main kind of sections that you want in all of your reports. Now you can, this is in poster format, but this could have easily been presented in using PowerPoint, or it could have been typed up on Word, or it could have even been just written into their copy. So there's a number of different ways that you can actually report your findings in an investigation. So if we take, these are the basic kind of, this is basically what you want in all of your scientific investigations. So you need a title, have an introduction. So generally in your introduction, what I like to say is to introduce or talk about some of the theory behind the science, that's going to be in the investigation. You want to always develop a hypothesis, so you're trying to answer a question. Ideally, you want to put it into the if-then format. You want to talk about the materials that you're going to use, so materials and also equipment as well. The method that you're going to use. So remember, to make sure that the investigation is fair, you also want to have a method. It's always a good idea then to have a labeled sketch of the method used, or a diagram, something like this. So it just kind of gives you can look at it, we're very visual, and you can see kind of like roughly what the experiment is about. You always want to have like a table of results. So when you carry out your investigation, you're going to generate a table of results. So you want to, so see, like we have a table of results here. Then you want to look at the table of results and analyze them. and see like what does the table of results tell us in relation to the investigation. And then you want to kind of write up some kind of a conclusion based on your analysis of the results. And this conclusion will generally kind of try and answer the question that you started out with. So this is like, what are conductors of electricity? And there's a number of different materials, and we can see whether they conduct electricity or they do not conduct electricity. So we're going to get you to carry out this experiment, and I'm going to talk a little bit next now about the theory behind it. But when it comes to the overall learning outcome for this section, it's to realize that like these are the kind of main things that you want to have in your write-ups when you write up your investigations. And it's just realize that you can write them up in different ways. So you can write it up like a poster like this is something that I like students to do. You can also use PowerPoint to write up the same report, or you can like write it into your copy, so you can. And again as well, you always want to have it so that it's clear, like it's easy for somebody to understand it. So imagine it's somebody that's reading it that has never like done science and is just looking at this for the first time. So they need to be able to understand what the report is actually about. So that's the way you kind of need to think about it. When you're writing up your reports, think about your audience, make it as easy and as straightforward as possible. So this investigation, like what was it about basically? It was about setting up a circuit like this, and this circuit allows electricity to flow around through the circuit. So when the electricity is flowing through the circuit, the light on the circuit is lit, and the minute you interrupt that circuit, the light will go out. Okay, so that's kind of like that's what the investigation was about. So let's look a little bit at the theory of electricity and the theory of conductors and insulators. Okay, so this is the procedure that you're going to use or follow to carry out the investigation. So are metals good conductors of electricity? That's the kind of main method, that's what it's about. But you can modify this, because you're not only going to look at good conductors, you're also going to look at other materials as well and see if they help to conduct electricity. So this is the equipment that you're using. Okay, so equipment needed. So you have a 6-volt battery. Okay, then you have these like clips that clip on to the battery. You have what are called leads. You have these crocodile clips, which are these guys here. They're called crocodile clips because they're kind of like a crocodile's mouth, and they can grab onto the material. And then you have like 4 different materials. So iron, copper, zinc, and aluminium. You're also going to have other materials as well that you're going to test. So basically, this is like the safety in relation. Always like consider safety when you're carrying out the investigation. And then these are the steps then that you follow then to conduct the activity. So what is electricity? So if we go right back to the study of the atom. So remember, we looked at the atom and you had the different parts of the atom. You had the proton, the neutron, and these were inside the nucleus. And then on the outside then you had these other subatomic particles called electrons. Well, all of electricity is based on electrons. So basically these tiny little particles, negatively charged particles, they are able to flow through material, and that essentially is what the flow of electricity is. So depending on the material, so if we take this setup here, so the battery, basically think about the battery as like a big store of electrons, and it has a negative terminal and it has a positive terminal. So what happens is the electrons are built up here on this negative side. So there's loads of electrons packed in here on this negative side, and they just want to get away from each other. And then in the middle there's like a divider, and then on the other side then there's this positive side. So what happens is the electrons, they want to get from the negative side of the battery over to the positive side of the battery, but they can't do that because in the middle there's what's known as an insulator that stops them from being able to just transfer directly from this side over to this side. So what will happen then is if you attach then the negative side, and you create a circuit to the positive side, what's going to happen is the electrons will flow through that circuit right the way around and then to the positive side. So you get this flow of electrons. And once all the electrons have flowed from the negative side and there's no more that are able to flow, then what happens is the battery is dead. Okay, so it either needs to be recharged or you need to get a new battery. So essentially you can think about it like this. So imagine if you were to zoom in, let's say, to this. So this is a circuit, or if you think about it, it's like the path that the electrons can move through. So what will happen is, if all of the materials on the path are good conductors, what's going to happen is the electrons will move freely through the materials, right around through the circuit and over to the positive side. That's essentially what happens. So copper, for example, is a good conductor. That means that copper allows electrons to easily flow through the material in it. So the electrons will literally flow through copper. That's why we make most of the electrical work that's done in your house is copper wires. And the clips, so these, for example, these leads here will be made out of copper. Then what you have then are these things called semiconductors. And basically what they do is they don't let the electrons move through the material as easily as copper, and they kind of resist it. Okay, so that's why they're called semiconductors. They kind of resist it. So silicon is an example of that. Another material as well is what's called tungsten. So inside the bulb here, there is a material called tungsten. So what will happen is the electrons will flow through this, and tungsten doesn't allow electrons to flow through it as easily. And what will happen is that will create resistance, and the element will get really hot, and it'll get so hot that it'll actually glow. And that glowing then is the emitting of light. And what happens is that's what we use for, that's why we use a bulb to emit light. And then we have, let's say, it's like a really poor conductor, something that will not let electricity pass through it, and that's materials like glass. So for example, glass are what are called insulators. They're called insulators because they will not let electrons move through them. And if you take the leads here, so the leads will be covered in a plastic, and that plastic is an insulator. If that plastic wasn't there, what would happen is you would get electrocuted when you touch the wire, because the electrons would move through the wire and move through your body, and you become like what's known as you get electrocuted basically. So you have this circuit here. So once this circuit is made up of like good conductors of electrons, the light will light up. Now what we can see is that in the middle here, we can actually take out a piece of material and put in another piece of material. And what you're going to do is you're going to test all different types of materials, and you're going to see like what are good conductors and then what are poor conductors, or what are known as insulators. So you're going to try out a number of different types of materials in here, and that will tell you whether the material is a good conductor or a poor conductor. How will you know if it's a good conductor or a poor conductor? Well, if it's a good conductor, it'll allow the light to light up. If it's a poor conductor, the light won't light up when it's all connected up to the battery. The other thing then as well is that some materials will let some electrons through, and you might get a faint glow on the bulb, and these would be known as what are known as semiconductors. And all of this kind of goes back. Electricity is based on this tiny electron that we learned about, these negatively charged particles called electrons. And basically what's happening is electrons are moving through materials. So this is the investigation that you're going to carry out, and then I'm going to get you to write up a report similar to this one here, and you want to take into account each of these headings then as well. And then also the other thing, when you're doing this report, you want to imagine that you are presenting the report to somebody that has never studied anything about electrons or electricity or anything like that. So you want to make it as easy and as clear for your audience or the person who's going to read the report, so that they can actually make sense of it. Okay, so that is scientific communications, and we will leave it at that.